Hello everyone. In this video, I am going to explain about the binomial coefficients, which is a class 11 topic. First, what is binomial? If the given expression contains only two terms, then it is known as binomial expression, isn't it? In the polynomial, we have learned what is a binomial, trinomial, a multinomial, etc. Right? So binomial means if an expression contains two terms, then it is known as binomial expression. So examples I have given. So here a plus x two terms. Here a plus b two terms, which is having a power 2. Power might be anything. A plus b whole cube or a plus b whole power 4. Power might be anything. If the expression contains two terms, then it is a binomial expression. Now our topic is binomial coefficients. What are these coefficients? Let's understand. The coefficients are the number of ways picking unordered outcomes from the possibilities. These are also known as combinations. Binomial coefficients are nothing but in a set of objects. If we pick few objects without any order or without any condition, if we are picking a few items from a set of object without any order, then those outcomes are nothing but binomial coefficients. These are also known as combinations. The other name for these binomial coefficients are combinations. The coefficients are nothing but powers of x in the expansion of x plus a whole power n. What is this? Let's see. For example, we know the formula of a plus b whole square, right? A square plus 2ab plus b square. Okay. We know the formula for a plus b whole cube. A cube plus b cube plus 3a square b plus 3ab square. So, a plus b whole square, a plus b whole cube, we can remember the formulas and we can apply wherever we want. In a plus b whole square, the power is 2. So, we got here 3 terms. In a plus b whole cube, the power is 3. We got 4 terms. That means if the power is n, we will get n plus 1 terms. Okay. So, for writing this kind of formulas, we need to learn how to expand the binomial expression with the any power. So, for writing this kind of formulas with a different power, so we need to learn how to expand binomial expression with any power. So by learning the binomial coefficients, we can expand binomial expression which contains any power. Okay. So for that we have a formula here, x plus a whole power n. So x plus a is a binomial expression. Here it is having a power n. So how to write a formula for this? The general formula is nc naught x power n minus 0 a power 0 plus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 a square plus nc3 x power n minus 3 a cube plus so on ncn x power n minus n a power n. So if we want to expand with any power the binomial expression, this is the way. nc naught x power n minus 0 a naught a power 0. That means what we have done, first we have taken nc naught, nc0, x power n minus 0. These two things we need to subtract, and a power 0. Whatever here comes now, that is a power 0. nc1 x power n minus 1 a power 1. Okay, here n minus 1, these two you need to subtract, and a power 1. nc2 x power n minus 2 a square. So here if we observe one thing, x power is decreasing. First I started with n minus 0 means n, next n minus 1, next n minus 2, Next n minus 3. X power is decreasing and a power is increasing 0, 1, 2. So a is increasing, x is decreasing. So this kind of formulas, this kind of expansion if we want to do for the binomial expression, so we need to remember this general formula. So the middle term will be like this. NCR x power n minus r a power r. This is the general term. This is the middle term. Okay. So now the term ends here NC naught, NC1, NC2, all these are coefficients, binomial coefficients. The coefficients means nothing but these are the numbers, coefficients of the x. Okay, these are the coefficients of the x in the binomial expansion. So hence these are called as binomial coefficients. So the term NCR can be written as we can write like this NR, or also we can write C of N comma R, okay, where NCR is equal to N factorial by N minus R factorial into R factorial. N should be always greater than R. The condition is N should be greater than, always greater than or equal to R. NCR is equal to N factorial by N minus R factorial into R factorial. If we want to find out what is NC0 value, NC1 value, NC2 value, this is the general formula we use for these combinations. NCR is equal to N factorial by N minus R factorial into R factorial. N is here total number of objects. N is total number of objects. Okay. R is number of chosen objects. Chosen objects. That means NCR is nothing but out of n objects, R has been chosen. Out of n objects, R has been chosen without any order. Okay. Let's see. So this is about the binomial coefficient with the definition. And now let's see some important properties. Important properties. The first property. Sum of all coefficients. Sum of all coefficients means we will start with NC naught, the first coefficient, right? NC1, NC2, so on, NCN plus NCN till the last term. So if we want to do all the coefficients, the formula is 2 power n, just 2 power n. If we know the n value, we can find out sum of all coefficients easily. Next formula. Sum of even coefficients is equal to sum of odd coefficients. What are even coefficients? 0 is even, right? 0 is even, 2 is even, 4 is even. That means NC0 plus NC2 plus NC4 is the same as so on, is the same as odd coefficients. NC1 plus NC3 plus NC5, so on. So sum of even coefficients is equal to sum of odd coefficients, that is equal to 2 power n minus 1. Sum of even coefficients is equal to sum of odd coefficients, which is equal to 2 power n minus 1. Next, another formula, another property, NC naught. What is this? This is the first term. Okay. So always the first term is same as the last term NCN, and the value is always 1. NC naught and NCN, the first term and the last term, both the value is always 1. Next, in the similar way, the second term, what is the second term? NC1. Second coefficient is NC1. And the last but one coefficient is NCN minus 1, because NCN is the last coefficient. So the before coefficient is NCN minus 1. So NC1, NCN minus 1 is equal to N. It is a same as a N. And this is another property. Now let's see one more property. If NCR is equal to NCS. Okay, if NCR is equal to NCS, then we can draw some conclusions. R is equal to S happens, or R plus S is equal to N happens, or R minus S is equal to 0. So, based upon the question, we can use any of these results. If NCR is equal to NCS, then we can write R is equal to S, or R plus S is equal to N, or R minus S is equal to 0. Let's see one more property. NCR is equal to N by R into N minus 1 C R minus 1. Next. One more. NCR minus 1 plus NCR is the same as sum of these two is nothing but N plus 1 into N plus 1 CR. What I did here, N values are same. R and R minus 1. Okay. Consequent R values. Then we can add 1 to the N and we can take the R value, big number. Okay, N plus 1 CR. Next. Eighth property. NCR divided by NCR minus 1 is equal to NCR, and the before coefficient is NCR minus 1. Nothing but N minus R plus 1 by R. So these are the main properties of binomial coefficients. So just try to understand, but when we apply and solve few problems, so it is easy to remember. So in my next coming up video, we can solve few problems on the binomial coefficients. Please watch it. Thank you.